Hey everyone, welcome to my channel where we make math easy and fun. So today's video is about factor tree. Let's see how to make factor trees and how do we use them. Here we have a question. It says draw a factor tree of number 120. Let's see how it is made. Okay, first of all, we write the number on the top and then we draw two branches as here you can see, and we write two numbers which their multiplication becomes the number. Like here, 2 times 60, we get 120, which is the number on the top. Well, 2 is already a prime number, so I circled it. So every time we get a prime number, we should circle it, so we know we don't have to deal with them anymore. Now we have 60 here, which is not a prime number, so we continue with the branching again. There's again two branch, 2 times 30, 2 again, we get a prime number. So I circled it. Now we have 30. But the interesting thing you see is when you multiply these two numbers, 2 times 30, you get 60. And 30 becomes 2 times 15, then you get 30. And then 15 is 3 times 5, which makes 15. Now all these numbers that we get at the end are prime numbers. So this is how we create a factor tree. And also, all the prime numbers we got from the factor tree, we will write them together, which is what we call prime factorization. As you can see, number 120 has prime factorization 2 times 2 times 2, 3 2's, and 1 3 and 1 5, which is exactly written in the factor tree. If I elaborate them further, there are 3 2's, so we will write 2 to the power 3. There's 1 3, so here we wrote 3 to the power 1 because there's just 1 3. And there's 1 5, so we write 5 to the power 1 as well. There's another number, 150, which I created a factor tree here as well. Number 150, as you know, the rule goes, we have to write two numbers, but their multiplication has to be the number on the top. So 2 times 75 is 150. Well, 2 is already a prime number, so we circle it. Now we work with 75, again two branches, and you could come up with any number that multiplies, and the number on the top has to be the product of these two numbers. So 3 times 25, we get 75. And 75, after that, we get 25 here. Now we get 5 times 5, which makes 25. Now we have all these numbers are prime numbers, so I circle them. And when it comes for prime factorization, these numbers are exactly from the tree. As you can see, there's 1, 2 in the tree, so I wrote 2 here. 3 goes there, 5 and 5, so there are 2 5's. And to write them well, there's 1, 2, so I wrote 2 to the power 1. There's 3, as there's 1, 3, so 3 to the power 1 as well. And 5, there are 2 5's, so we can write them as 5 to the power 2. This is called prime factorization. Now the question comes, how we use these prime factorizations or the factor trees? Well, the question comes ahead is we use them to find the LCM and HCF of any number. So this is our next topic. Finding LCM and HCF using prime factorization. Now we just learned how to do prime factorization. Now we will use them to get the LCM and HCF of any numbers. To get the LCM and HCF, first we have to understand what does these two words mean. LCM means least common multiple. And when we find the LCM of any number, we have to follow these two steps. These are the rules how to get the LCM of any number. The first rule says take all prime factors present in any of the given numbers. Second is choose the highest power of each factor. What I mean is we will understand them a little in the future. HCF means highest common factors. And there are again two rules to find out HCF of any number. One says take only the common prime factors and choose the lowest power of each factor. Remember, when we find LCM, we have to take all the prime factors we found, but we only write the highest one. But in HCF, we have to get only those prime factors that are common in both numbers or three numbers. Choose the lowest power of each factor. Then we gotta choose the lowest power of each factors. Here's what I mean. Let's understand this by an example. The example question says, find the LCM and HCF of 120 and 150. There are two numbers. We have to find both LCM and HCF. Let's start. Step 1 is prime factorization. We have to find the prime factorization of these two numbers, 120 and 150. Well, recently, we just found the prime factorization of these two numbers already. You can go back in the video and find out how we get it. Now, once we have the prime factorization of these videos, the LCM, remember what the LCM says. LCM says take all the prime factors present in any number. So we have to take all the prime factors, but we have to choose the highest power of them. So let's see how many prime factors are there in both numbers. So we find 2, 3, and 5. There are three numbers. And in 150, there's also 2, 3, and 5. So the prime factors has the same number in both numbers. So let's find out. There's 2 here in 150, and there's 2 also in 120. So this number is common in both, but remember that we have to take the highest power. So we wrote 2 to the power 3. Next, we have 3. The highest power in this both case has 1, so we will write 1, 3 to the power 1. But again, we have 5 to the power 1 in 120 and 5 to the power 2 in 150. So we will take the highest power. So once we multiply them, we get 600. Now, what happens to the HCF? How do we get the HCF? HCF says we only take those numbers that are common in both. LCM, we took all these numbers, but only their highest power. In HCF, no. Imagine if there is 7 here as well, but 7 does not exist in the upper number, then we cannot take that one. So we have two. One has power 3, the other has power 1. So we take the lowest power for HCF. So we took 2 to the power 1. Now we have 3 in both numbers. So we will take the lowest, which is 1 in that case. And we have 5 in both numbers. So we will take 5, but the lowest power, which is 1, right here. When we multiply them all together, we get 30. So the LCM of 120 and 150 is 600, but the HCF is 30. Here is another example to make you understand the LCM and its HCF easier. Here the question says, find the LCM and HCF of 60 and 46. Well, 46, first we have to do the prime factorization. 46 has only two prime factors, 2 and 23. And since 60 is not a prime factor, so it has many prime factors like 2, 2, 3, and 5. So I just wrote them to make it easier for understanding. 2, there's 1, 2, so I wrote 2 to the power 1. There's 1, 23, so write 20 to the power 1. But in the 60, there are two 2's, so we gotta write 2 to the power 2. And there's 1, 3, so 3 to the power 1, and 5 is also 1, so we write 5 to the power 1. Now, as the rule goes, for the LCM, take all the prime factors but their highest power. So 2, we're gonna find 2, 2, 2, but we have to take their highest prime factors. So there are two 2's, the highest power is 2, so we'll take 2 to the power 2. And then 3 as well. Well, 3 is not in here, but it's here. So we'll take 3. Highest power factor would be 1, so we take 3 to the power 1. And the next number is 5. We took 5 because 5 doesn't exist in 46. So we take 5 to the power 1 as the highest power. And again, 23 to the power 1 as the highest power of the number. So remember, when we take LCM, we take all the prime factors together with their highest power. Once you multiply them, you will get 1,386. When it comes for HCF, HCF means we have to find only those prime factors that are in common, that are in both numbers. In this case, there's only one number, 2, which is common. You can see 3, 5, and 23, they are not in both numbers. So in this case, we take only number 2, and we also have to take the least or the lowest power. So 2 to the power 1 is the lowest power in these both numbers. So we take this number, and that is 2, which is the HCF of these two numbers. Hopefully you get what is prime factorization and how to do it, as well as the factor tree and how to get a factor tree of any number. Now here I have some exercise for you. I want you to find the LCM and HCF by factorization, prime factorization method, and write the answers in the comment. I'll see who gets it correct. That was all for today. Thank you very much. See you, bye.